So tonight I'll be presenting how to use MongoDB as a central queue for distributed job processing. It's kind of a mouthful, but I wanted to be very specific what I'm doing. This photograph I thought was a good analog of what we're doing. It's a group of homogeneous workers producing uniform output in parallel. This photograph was taken by Canadian photographer Edward Bertinsky. It's part of his series in China. He also has a documentary about his work in China, which is available on Netflix Instant. It's called Manufactured Landscapes. There's a lot of stunning photographs like that because everything is like large scale. I really like it. So I'm Shaddy Zeineddine. I'm a PHP developer at BreakMedia. The stuff I'm going to be talking about tonight is from my experiences developing a web services API for them. The web services API, it started as, it's a centralized collection of non-trivial services used by two or more of BreakMedia's owned and operated properties. Their most significant properties are break.com and mademan.com. And by non-trivial, I mean things that you couldn't just easily implement multiple places. And the first thing they wanted was centralized searching. And one of the main reasons they want it is because they want to be able to show content from one site on another that's related. They were currently paying someone else for this service, and they wanted to do it themselves. The other thing they wanted was video encoding. So those are the things I started off with. These are the high-level requirements that I translated from what they gave me. They weren't this clear before. But the last one is a very important one: scalable, load balanced, and highly available. If you want to do that with MySQL, it's not very simple. Doesn't come out of the box at all. So this is the design that I came up with. Some of it was influenced by choices or suggestions or recommendations that were there before I started. The project had been desired for about a year before I got there. It just never was finished. So the way it works is a property which represents one of the websites will add a document. This is for the search. Will request to add a document to the index. That goes to a LAMP server, part of the app cluster, which then stores it into the Mongo replica set. That allows us to pool our updates to the Solr index, and it also is sort of an online backup so that if we need to rebuild the index at any time, we can. So if we have a big schema change, we just rebuild one index like that. A lot of times I hear people explaining why they chose MongoDB for a project, and I'm usually not very satisfied with what they say. It seems that they just tried it out, they liked it, so they kept using it. But for this project, I thought MongoDB was a really good choice. And there's some reasons here I want to go over. The first one is that I believe it's a natural fit for our data. Our data is, so let's take a video encoding job for one. So the video encoding job, you request this job. It's this complex object which has these parameters and nested formats, and what I do is I just take it as is. The request is in JSON. Take it, I convert it into an object by basically just setting all the properties to the array, and then I convert that back into an array and just throw it into the database. It's really simple. There's almost no code to work with the data. If I were to do this in MySQL, I would have to, take this object, break it apart into like 4 or 5 different tables. The next thing I want to go over is Tengen. The company is really active in the community. They have a lot of support, a lot of documentation. Even if you don't know anything about databases or anything about MongoDB, you can find whatever you need to get it started. That's really important to me. I feel that the company will be around for a long time and continue to improve their product, and I've been really happy with their work on the PHP client driver. They have, I think, 2 dedicated developers on that, and they put out new versions all the time. It's amazing. The last things are developer-centric. Okay, so traditional database, you have something like this. this ugly schema that, and the schema is stored in the database, but the application is also aware of the schema. So you have a duplication of roles. If you change something in the database, you have to usually have to change something in the application, and vice versa. So I really like that MongoDB decided to take the schema out of the database, and now it's only stored in the application. This makes it a lot easier to make changes. I was just reading on the Etsy blog about their whole system to update their schema. They have this really sophisticated system called I can't remember the name of it. But like with MongoDB, you wouldn't need something like that. You could just focus on the application. And if you have good developers who understand your database, which you should, then it isn't a problem. And I never miss seeing pictures like this. So the other thing I wanted to talk about is the lack of joins. So I don't see that as being a problem. I see relying on joins is a problem. If you want to scale your application, if you're going to have high load, you can't really use joins. If you ever want to shard your database, you're going to have to forego joins. So if you're using MongoDB, it kind of forces you to design your application in a way that scales really well. And I like that too. So the project that I created presented like some different cases where job processing was necessary. So I mentioned that every 5 minutes we index the documents or update the documents in the index. And I could have done that with a cron job, but if you have 2 servers, you need to have them alternate every 10 minutes on each one with the offset. And if you add another server, then you have to modify all of them. So I decided to just write my own cron in PHP so that I could just add an arbitrary number of servers. They would only do one at a time. And I could also keep the cron tab stored in the application and never have to worry about deploying it separately. Some of the other things have some unique features about them, like the callback processing. So when I send a callback for, let's say for video encoding, your format is done, or all your formats have been completed. I send a ping some URI or send an email to an email address. Well, if that fails, I want to try it again. But I don't want to try it right away. So I have a delay. And if it fails again, I delay an even longer amount. So these are some unique things I had to deal with when I was designing the system. So I realized there's a lot of similarities, more similarities than differences between these 4 systems. And I was like, okay, I can figure out how to do them all with the least amount of code. Took me a few iterations, but these are the 3 classes I created, and they're used for all of them. And there's very little additional code that I needed to customize them. The cron job one has the most customization. And I'll go over what these things are. So the job has that toArray method. That's how I convert things to send them into MongoDB. I have that in almost every one of my objects that I store in MongoDB. It just turns it into an associative array. And then usually for the constructor, it converts it from associative array back to that object of a class. For the Q class, worker identifies the current worker. So that could be either the process. It's always the process on a server, because a server can have more than one of the worker processes. And then the main ones in Q and DQ. Pre-enqueue and pre-dequeue are just ways of hooking into this class to add custom functionality. If you want to do something before you enqueue or dequeue, that's how you do it. New job, the class, the implementation those are abstract. New job and get priority abstract. So if you want, once you dequeue a job, it comes back as an associative array, and then it calls that function to convert it into the object of the class. And sometimes it requires some extra code to convert it. I'm going to go to the next one.
Was this only designed to be run on one machine or across a network?
It's across the network. So you have,
But I mean, you can DQ, you can send jobs to different machines.
yeah.
Right.
So, like if you wanted to target a specific machine,
When you said the worker was just the ID to a process, I wasn't sure if you just meant process on the local machine.
so what it is like for video encoding, we don't want to download the video to more than one machine at a time. So once one machine pulls in a job, it locks it into that machine. So now the worker would be set to that name, so another box or another process couldn't try to DQ it again. It has to be only this one. Other things is like that's another way to tell if it's being worked on. If that value is set to something, then I know it's being worked on something. And if the job fails and the machine is restarted, I can reset anything with that worker. So like if you restart your processor, then it knows to re-queue everything with its worker ID in there. There are some other values to change the number of processes per I'll explain it here. So each server gets a collection of one manager parent process that controls a bunch of worker processes. There can be either one worker or there can be arbitrary number. The manager handles starting and stopping of the child processes. If you, for instance, kill the parent, it will kill its children. And if you send a signal, control C it will make sure that the workers die too. Then the workers do all the actual work. They pull the queue, process the job, and when they're done processing, they don't get reused. They just exit, and the manager will spawn a new one in its place. That's to prevent any kind of it's to isolate these processes. I haven't had a problem, but I just figured it was best to do it that way.
You configure how many processes run per box?
Yeah. So for the cron job processor, I have one per box. For video encoding, I have the number of CPUs divided by 2. For callbacks, I think I have just one per box because it's not very important. So I know this is about MongoDB, but I think the best part of this is that I barely have any database interaction in my code. There are a total of 3 queries that I have in all of this. One to DQ, one to enqueue, and then there's a separate one that's rarely used to update priority, which I use when I want to increase priority over time. So if a job is sitting there and it's not getting processed, every so often I calculate how long it's been waiting and increase the priority so that the longer a job waits, the higher priority it becomes. But otherwise, there's just 2 queries. This is the one to enqueue it by default, and it shows what kind of parameters it adds. I add the time queued, worker, and priority in addition to the object itself. And then for cron jobs, they're very different. I developed the cron job thing first, so I had different names for the properties. Run at is sort of its priority. Locked is kind of equivalent to worker. When it's being processed, it shows the value of the process that's working on it. For dequeuing, I have a method called doDequeueQuery, and I pass in the default query to dequeue, and then you can override that method if you want to do something different. So by default, that's what it does. It makes sure that worker is either equal to the current worker or it's blank, and then it sorts in descending order of priority. And it also, by default, will remove the object from there. And it uses find and modify, which is really important. It prevents other processes from getting the same job at the same time. I love that method. For cron jobs, I've changed it significantly. It does still filter by the worker, which is what locked is. But after it gets the next process next job to process, it calculates the length of time before it's supposed to be processed, and it'll sleep that length. This is the cron tab for it. It's very similar to a regular Unix cron tab. The only difference is that the names, instead of a command, you give it a name of the class that you want to process, and there's an optional second parameter, which is a JSON object of whatever data you want to pass to it. So some of the challenges that I didn't find a really nice solution for were when a job fails. For the most part, I usually have a secondary collection to store the jobs to, for instance, video encoding, which is somewhat necessary because for historical data, if somebody wants to get the status of a job that's done and processing, I still need to store it somewhere. So for video encoding jobs and for uploads, I have two collections. I have the queue and I have the storage collection. And when a job fails, then I have another cron job that checks to make sure that a job is complete. If it's not complete, it puts it back into the queue and gets processed. When a worker is terminated while processing a job, I would love to be able to resume where I left off. And for video encoding, if I finish a format, I do maintain the progress. But it just adds more complexity to the system. And then maintaining progress. So the way I store stuff in Mongo is I usually just store the whole object as is. I don't do partial updates just because then I would have to know what is getting updated and either have more complex code or basically more complex code. So I just tell it to save the thing and it saves the whole object. And if you're doing progress updates and the object is kind of large and you have a high load, it could become a problem and you might have to more intelligently figure out which data is changed and only update that data. Thanks for listening.